Hi, welcome to this lesson on probability counting principles part 1. Let's have a look at question 1. How many 4-digit numbers can be made from the list 1, 2, 3, 4, 5, 6 if repetition is allowed? Okay, so we have 4 digits to fill out and we have 6 options for the first digit. And because repetition is allowed, I can use the same 6 digits to choose from again. Same for the third and same for the fourth position. So by the fundamental counting principle, I multiply these and get 6 to the power 4. And if we pull that up, let's see what that is equal to. So 6 raised to the power 4, and we get 1,296 different possible 4-digit numbers that can be made from 1, 2, 3, 4, 5, 6. If repetition is not allowed, well, again, we still have 4 spaces to fill. Okay, but now we have 6 digits for the first number. But because we've chosen one of those 6, there are 5 left for the second number. Then there'll be 4 left for the third number and 3 left for the last number. So by the fundamental counting principle, we will simply multiply those 2 values together, or those 4 values together rather, and get the solution. So 6 times 5 times 4 times 3, that's 360. Can you see that 360 is a much smaller number, okay, than the previous one that we got, 1296, because again, here we have a restriction imposed. In this case, repetition is not allowed. What if the first number must be even and the digits cannot be repeated? So again, 1, 2, 3, 4 different places here. But for the first number, because it must be even, we have to choose from 2, 4, or 6. So there are 3 different possibilities we can choose for the first number in that 4-digit number. And because digits cannot be repeated, that means since we picked one of these, there are 5 left in total out of the 6 numbers remaining. Then there will be 4 numbers left and then 3 numbers left to choose from. Okay, so the total number of ways by the fundamental counting principle is 3 times 5 times 4 times 3. Okay, so let's do that. 3 times 5 times 4 times 3. That'll give you 180. Can you see that's exactly half of the 360 we found in the previous question? And let's think why that's true. Well, first of all, repetition not allowed gives us that 5 times 4 times 3 in both of them. But instead of having 6 options for the first, can you see our options were cut in half? And that makes sense because they said the first number must be even, and only half the number of elements in that set, 1 to 6, is even, namely 2, 4, and 6. So it makes sense it's half that number. The last number must be odd, and the digits cannot be repeated. So again, 1, 2, 3, 4. Okay, so first of all, we know the last number must be odd. So I immediately go to the last number and I say, well, there's only 3 odd numbers in that set, 1, 3, and 5. So there must be 3 numbers. That has to happen. Once you've chosen that last digit, then there are still 5 remaining digits left for the first digit, then 4 remaining, and then 3 remaining. So by the fundamental counting principle, this is exactly as the same as this last one, just that now, in this case, instead of the first number being odd, the first number being even here, the last number must be odd here. So this will give us 180 different 4-digit numbers. Lastly, the first and last number must sum to 7, and the digits cannot be repeated. So again, let's think of the possible ways that this could happen. So the first and last numbers over here. Well, which 2 numbers in the set will add up to 7? Well, 1 and 6 will add to 7, 2 and 5 will add to 7, and 3 and 4 will add to 7. Okay, so there are 3 different combinations, or 3 different options rather, that we can choose from. Okay, so it could be 1 and 6, all right? In this case, if it's 1 here in the first one, then it must be 6 in the last one and 1 here. Then in the second ones, instead of 1 and 6, you could have 2 and 5 or 5 and 2. And then the last ones here, you could either have 3 and 4 or 4 and 3. Okay, so those are all rather here, or. Okay, so let me put the words or here. Take that away. Okay, so let's do the counting here. So if I choose 1 as my first, then 6 has to be my last digit. So there are still 4 possible numbers to choose from here. So there are 4 factorial different ways we can arrange those numbers in between here. So for example, 2, 3, 4, and 5. Of those 4 numbers, they can be arranged in 4 factorial ways. And the same thing is true for here, 2, 3, 4, 5. There are 4 factorial ways in which those numbers can be arranged. Okay, so for this first option here, for counting, there are 2 digits to choose from, either 1 or 6. Okay, in the next space, there are 4 factorial ways of arranging the leftover numbers, 2, 3, 4, and 5. And then lastly, there must be only 1 number left here on the outside. So if you chose 1 here, then it must be 6 at the end. If you chose 6 here, then it must be 1 at the end. Okay, what about this combination here, or this option rather? Okay, so here again, these are taking 6-digit numbers. We are looking for 4-digit numbers. So again, you just got to be so careful, so careful. Okay, so I'm going to just get my eraser here. So remember, we are looking for 4 positions. So the first position and the last position, there will still be 2 ways to choose the first one and 1 way to choose the last one. So there are 2 numbers here, so there can only be 2 numbers left over here. And there are 4 numbers to choose from. So it's not 4 factorial. Okay, what should it rather be? There should be 4 different options for that second digit. And because you can't repeat, then there must be 3 digits left. Okay, so it's 2 times 4 times 3 times 1. Okay, that's better. Make sure your logic when you're doing it makes sense. I was doing 6-digit numbers, but we were asked for 4-digit numbers. The same thing here. Of these 4-digit numbers, okay, there are 2 options for the first one, either 2 or 5. And then depending on which one you pick, there's 1 digit left in that last number. And again here, the numbers 1, 3, 4, and 6 can be chosen in each of these options. Okay, again, there are 4 numbers here, so there are 4 to choose from. Once you've chosen one, there are 3 left. Okay, and there's the multiplication. And then lastly, in this scenario of the 4 digits, you could choose 3 or 4 first, so there are 2. And once you've picked one of them, there can only be 1 at the end. Okay, again, that's because the first and last number must add up to 7. And again, there are 3 digits here. There's 1, 2, 5, and 6 left to choose from. So out of the 4 digits, you can choose 4 for the second place. Once you've chosen that, you can't repeat it. There must be 3 left. Okay, so how many are there? There are 3 amounts of these numbers. 2 times 4 times 3 times 1. Okay, well, look at this. I can just rearrange this as 3 times 4 times 3 times 2 times 1, because the multiplication is commutative. But this guy here is 4 factorial. So it's 3 times 4 factorial. Okay, so we can do that on our calculator and just check. Or you could just type it out as you see it. Same thing. Okay, so 3 times 4 factorial is 72. Or if you did it this way, 3 times 2 is 6. 6 times 4 is 24. 24 times 3, that'll give you 72. Okay. All right, so that is the first question of counting principles. I'll see you in the next one.